All right, let's jump right in. We often think of math as just a bunch of boring rules and numbers, but it's really a secret weapon for solving puzzles. Today, we're grabbing one of the coolest tools out there, simultaneous equations. Stick around and you'll see how a little bit of algebra can crack some really tricky problems.
So, to kick things off, let's just forget all the technical stuff, okay? Forget the formulas, forget the textbooks. Let's just start with a fun little brain teaser.
Okay, here it is. I'm thinking of two numbers. If you add them up, you get 12. If you subtract the smaller one from the bigger one, you get 2. So, what are they? Now, you could just guess, right? Let's see. How about 10 and 2? Sum is 12? Check. But their difference is 8, so nope, that's not it. Okay, what about 8 and 4? Sum is 12? Great. Difference is 4. We're getting warmer, but still not quite there.
Yeah, you could keep guessing, but what if the numbers were like huge or weird fractions? That would take forever. Well, the great news is we don't have to guess. Algebra gives us this super precise, really powerful, and honestly, way cooler method to nail the answer every single time. And this isn't just for fun. It's the exact kind of thinking that lets engineers build bridges that don't fall down.
So this awesome tool that lets us ditch the guesswork, well, it's got a name. It's time we properly introduce ourselves to the star of the show, the linear equation.
Okay, don't let the fancy name or all the letters throw you off. A linear equation is just a simple way to describe a relationship between two mystery values, which we'll just call x and y. Think of it as one clue in our puzzle. It's like a single story about two characters. For our puzzle, the first story is simply x plus y equals 12.
That's it.
Story number 1.
But you can't solve a mystery with just one clue, right? You need more. That's where the simultaneous part comes in. It just means happening at the same time. We have a pair of these stories, and they're both true, for the same two characters at the exact same time. And our second story? That's x minus y equals 2.
And here's the absolute key, the most important thing to get. We are not looking for one answer that fits the first story and a different answer for the second. No, we are hunting for that one special pair of numbers, the one x and the one y, that makes both stories true. It's the one point where these two different plots cross over.
Okay, so how do we actually find that magic point where they cross? Well, the good news is you've got options. It's not a one-way or the highway kind of deal. Let's open up our equation-solving toolkit and check out the gear we've got.
First up, we've got a method called substitution. And honestly, the name says it all. It's all about making a smart swap.
The way it works is actually pretty slick. You take one of your equations and you mess with it a bit until you get one variable all by itself. So it says something like, hey, x is the same thing as all this other stuff. Then you take that stuff and you substitute it, you swap it in for the x in the other equation. And just like that, boom, that second equation now only has one mystery left to solve. And you can see exactly how this plays out right here. We take that first equation and twist it around, so it says y is the same as 7 minus x. Now we've got a new identity for y. We just pop that expression into the second equation wherever we see a y, and bam! The puzzle suddenly got a whole lot simpler.
Okay, tool number 2. This one's called elimination. And if you like making your problems just vanish, you're gonna love this one.
So here's the game plan. You stack your two equations right on top of each other. The trick is to multiply one of them, or maybe both, by just the right number. Your goal is to get one of the variables to have matching numbers but opposite signs. Think a positive 5y and a negative 5y. Because then, when you add the two whole equations together, poof, that variable cancels itself out. It's eliminated. And check this out. This is the magic in action. See how we've got a 3x up top and a 5x on the bottom? We do a little strategic multiplying, and now we can make the x terms match. Subtract one equation from the other, and the x's are completely gone. All that's left is a simple little puzzle with just y in it. So slick.
All right, our last tool. I like to think of this one as the pro-level shortcut. This is for when you just want to cut to the chase and get the answer, like right now.
Okay, I know what you're thinking. That formula looks like a bit of a monster. But listen, don't sweat about why it works. Just think of it like a recipe. You just have to plug your numbers into the right spots, follow the cross-multiplying arrows, and it literally just spits out the answer for x and y. No heavy lifting, just follow the pattern. So, there you have it. Our toolkit is loaded. Substitution, elimination, and cross-multiplication. But you know, these little number puzzles are one thing. Let's step up the difficulty and see how these tools handle something that looks a lot more like a messy, real-world problem.
Whoa, okay, take a look at this one. We've got ratios, we're talking about 7 years from now. This is for sure a level up. And I get it, these word problems can look intimidating. But really, if you strip it all down, it's the exact same thing. Just 2 stories disguised in words, waiting for us to turn them into algebra.
And the game plan never changes. Step 1, and this is the most important part, is just translating the English into math. That first sentence about the ratio, that's equation number 1. The second sentence about 7 years later, that's equation number 2. And once you've got those 2 equations written down, I promise the hard work is done. All you do then is grab your favorite tool and let it do its thing.
So we feed those 2 equations into the system, we turn the crank, and what do we get? Bam! Person A is 18 years old and person B is 8. Just like that. No guessing, no am I close, just the one single perfect answer that makes both of those stories true. That is the power we're talking about.
Okay, so let's take a step back for a second and look at the big picture here. What's the main takeaway from all this?
I mean, this slide really sums it up perfectly, doesn't it? On one side, you've got your 2 different stories, your 2 separate rules from the age problem. And on the other side, you've got the one single meeting point, the one solution, x equals 18, y equals 8, where those 2 completely different stories meet and agree. It's awesome.
And believe me, this isn't just for made-up math problems. This concept is running quietly in the background of your life all the time. Every single time you use GPS on your phone, what your phone is actually doing is solving a massive system of equations, figuring out the one single point where signals from a bunch of different satellites all intersect. So, here's a thought to leave you with. What other invisible systems, what other intersecting stories are secretly shaping your world right now?